So good afternoon, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. We are all about bringing conservation, adventure, and science into classrooms around the world. And we are particularly excited this April because all month long we are celebrating climate research and showcasing climate change. And that's all made possible by Environment and Climate Change Canada, who's sponsoring our entire month of Hangouts, over 40 Hangouts on this topic. So it's really exciting that we get to highlight this with so many amazing people from around the world. And thank you guys for being a part. Right now, we've got 4 classes live from across North America. I'm going to give them a chance to do a bit of a shout out before we dive right in. We've got Miss Parks, grade 6 through 8 in Fallon, Nevada. Hi, guys. We've got Miss Goddard's grade 4 through 6s in Stratford, Ontario. Hi, guys. Getting so many Stratford classes lately. I love it. We've got Miss Langlois, grade 6s in Sterling, Ontario. Hi, guys. And we've got Miss Ramirez's grade 5s in San Antonio in Texas. Hi, guys. Awesome. Of course, the reason you guys are all here today is for our speakers. So we are joined live in Minneapolis, Minnesota by Jenna Totz. She is the Climate Change Education Manager at Climate Generation, a Will Steger Legacy project, for a lesson about climate change and what we can do about it. As I said, all month long, we've been showcasing climate change research, but today Jenna's really going to dive into how you guys as classrooms and as students can make a difference. So we're really looking forward to that. Our 5th class just joined us, Ms. Tishkov. Hopefully they get their mic working and can hear us. But without further ado, thank you so much for joining us, Jenna, and take it away.
Great. Thank you so much. I'm so excited to be here with you all. I'm just going to get my screen shared so we can hop right into this presentation. All right. All right, so today I'm going to talk to you about what's up with climate change. Like Joel said, I am Jenna Totz. I'm the Climate Change Education Manager at Climate Generation. We're a nonprofit in Minneapolis, Minnesota. And actually right now, I did not go to work today. I'm in my house because we are in the middle of a spring blizzard. It has been snowing and blowing. The wind is ridiculous right now. So just a little bit of a climate change situation that we've got outside right now. But just a little background about me. I graduated with a degree in secondary education. I was actually a an 8th grade earth science teacher for 5 years. And then I've been with Climate Generation now for another 5 years. Our mission is to empower individuals and their communities to engage in solutions to climate change. We do that working with 4 different groups of people. We work with youth, like the amazing classrooms that I get to talk to today. We work with educators to help them understand how to teach climate change to their students. We work with the public, just anybody that wants to learn more about what they can do to solve climate change. And influentials, elected officials and business leaders, like the head of Best Buy or Target, or different organizations that really want to make a difference on climate change. So just a quick presentation outline. We're going to talk about this guy, Will Steger. He was our founder. I'm going to present 5 climate change facts to help you understand what is happening and then also what you can do. And then I want to give you some time to ask all of the questions. All right, so Will Steger founded our organization about 14 years ago. He's a polar explorer and educator. That's him right here in the front. He's a recognized authority on the polar regions and has been an eyewitness to the effects of climate change really across the entire world. In 1989, he and a team of 5 other people trekked across Antarctica, and they followed this red line, and it took them 220 days to cross the continent of Antarctica by dog sled alone. And that's 3,700 miles. And that took them through March of 1990. Where's Will right now? I just looked up his position. He's on a solo expedition right now. So this is where he lives in Ely, Minnesota. And he flew up to the Barren Lands of Canada about 3 weeks ago and has been on a solo adventure ever since. So he's making his way up to the Arctic Circle on a adventure by himself. And he is 75 years old right now. So he's a pretty impressive guy. And he created Climate Generation back in 2002. And what had happened is that he opened the newspaper one day and was completely surprised that this ice shelf off of Antarctica had completely disintegrated. All of the ice just crumbled into little tiny icebergs in a couple of weeks. And it had taken his dog sled team over a month to get across this ice shelf. So this was really the effects of climate change happening. And he decided that he needed to create an organization to educate people about the effects of climate change and the solutions that they can engage in. And that's what we still do today. So my first big climate change fact is climate change is real. It seems pretty simple, but we want to start there. And so what we can see in this picture here, and maybe you've talked about the greenhouse effect in your science class, maybe you haven't yet, but we have two pictures here, the natural greenhouse effect, when light comes into our atmosphere, gets absorbed by the planet, some of that is re-radiated out into the atmosphere, maybe out into space, but some of it gets captured by these greenhouse gases, carbon dioxide, methane, and nitrous oxide, and we need the greenhouse effect in order to live on this planet. It makes it habitable, it makes it warm enough for us to live here. But what has happened over time is that we have emitted more of these greenhouse gases, and therefore more heat from the sun is trapped in our atmosphere, and we are warming our atmosphere. This is a graph that shows the change in temperature, or how different the temperature is each year, starting in 1880 all the way to 2016, each year. So if the line is blue, then it was a colder than average year. If the line is red, then it's a warmer than average year. So without talking, I would like you to raise your hand if you were born after 1978. And just look around quietly at your classmates. And I bet every classmate has their hand raised right now. And what that means is that everybody raising their hand has lived in a world that is warmer than average. And that includes me. I would be raising my hand as well. Great, thanks. You can put your hands down now. And how do we know this is happening? Well, we observe and we take measurements. And these are the measurements of carbon dioxide taken in Hawaii. And we see since 1959 that the numbers of carbon dioxide keep going up. We keep adding more and more to the atmosphere. And actually, this was from 2016. And so we're actually a little bit higher than that. We're about 409 parts per million. So there's a lot of carbon dioxide, meaning there's a lot of ability to absorb heat in our atmosphere. We can also go back hundreds of thousands of years in order to see what is happening with carbon dioxide. So when we look back 400,000 years, there weren't any people, but we can look at ice bubbles in glaciers and in ice sheets in Antarctica and Greenland. We can look at the seafloor in coral, and we can see how much carbon dioxide, measure that. And then when we put it on a graph, we see that we haven't had more than 300 parts per million until recently. And since the Industrial Revolution, we've added a whole lot of greenhouse gases, and therefore we have a whole lot more capability of warming our atmosphere. So my second fact is climate change is happening right now. This isn't something that's happening in the future. We're already seeing the impacts of it. So some of the climate trends across the US and Canada are an increase in temperature. We're seeing more extreme weather, things like snowstorms like we're experiencing right now in Minnesota, more flooding and droughts. We're also seeing ocean acidification. As there is more CO2 in the atmosphere, the ocean actually absorbs a lot of that. There's more ice melt. So glaciers and ice sheets in the northern and southern hemisphere are melting at a faster rate than they used to. We're seeing more powerful hurricanes and more precipitation. And I do apologize for our Canadian audiences that this is just a map of the United States, but you can see that there is a lot more heavy precipitation events, especially on the East Coast of the United States. So one really important thing that I want you all to remember is the difference between weather and climate. This is something that a lot of adults don't understand. So if you can remember this, you're doing well. So climate is weather measured over a long period of time. Weather is what's happening right now in one particular spot. Okay? A couple of analogies. Weather is like what you wear. Like, look at your clothes today. What are you wearing? Maybe it's warm and you're wearing shorts. But do you wear shorts every day? in your area? Or would you wear shorts every day on this particular day? Maybe not. Climate's what's in your closet, what's long-term in terms of what you might wear over the whole year. And then the same thing, weather is like your mood and climate's like your personality. Again, weather is short-term, climate is much longer term. The third climate change fact, humans are causing climate change. So these are our biggest sources of greenhouse gases, everything from burning coal to landfills, transportation, thawing permafrost in Russia and northern Canada. All of those things are releasing greenhouse gases and therefore giving us more greenhouse gases to warm the atmosphere and therefore change the climate. 97% of climate scientists agree this is happening and that humans are the cause. And that's a huge percentage. So we really know that this is happening. These are climate scientists that have their highest degrees in the science, and they really understand what's happening across the world. The fourth fact is that it's urgent, and we really need to act quickly because of that. So if we look in the United States, the number of billion-dollar weather and climate disasters are listed here. And so these are disasters that have cost over $1 billion in damages, everything from fire to hailstorms, drought, tornadoes and severe weather and hurricanes. And each year these are getting more and more numerous. We're having many more storms that just cause a lot of damage. There are several systems that are very vulnerable to climate change. One of them is our food supply. You think about having a garden or growing fruits and vegetables and things. If we have higher temperatures, that can lead to more drought, which can affect our food supply. We can also have more extreme weather events, which gives us more floods and hailstorms, which can damage crops. Our water systems are vulnerable. We have more evaporation because of higher temperatures. And because of higher temperatures, we can have more diseases in our waters and more algae blooms. And global health is also at risk. There's more pests like mosquitoes because it's warmer and wetter. And you also think about more pollution and warmer temperatures that can lead to more asthma or other respiratory issues. And we also want to remember that not everyone is affected the same by climate change. They're not all impacted equally. People that live near power plants in places that burn fossil fuels are going to be more negatively affected by things like asthma and air pollution. And so we just want to remember, maybe you don't have a story to tell about how you're affected by climate change, so you might not think about it too often, but there are definitely people in your neighborhood, in your community, especially in your state that or province that have been affected by this already. So why is climate change so difficult to fix? Just have a very, very short clip of a video that we produced a couple years ago to explain this. Or not. Here we go.
If greenhouse gases and CO2 coated everything in purple, we probably would have solved this 50 years ago. The thing that makes climate change so challenging is that you can't see the pollution. It's clear, it's colorless, it's odorless. It's the waste gases of progress.
So what Paul Douglas there is saying is that carbon dioxide and other greenhouse gases are invisible. We can't see them. It's a lot easier to explain to someone that their car is polluting because you can see what's coming out of the tailpipe, but we can't see carbon dioxide, so it can be very difficult. So it'd be kind of nice if it coated everything in purple. You know, we probably would have solved the climate crisis a long time ago, but just something to think about as we talk about the solutions. So all four of those first points were kind of heavy. You might feel sad or upset about the things that I talked about in those first 4 points. But we have the solutions to solve this problem, and you are part of the solution. So I want to talk about a few things that you as students can do in your classroom, in your communities, and then give a couple of things to your teachers as well, so that they have some resources to use. So a lot of schools participate in what's called Lights Out Day, and they are able to not use electricity, not turn on the lights for a whole day, just to raise the conversation about not using as much electricity. And it's just kind of an interesting day to kind of see what's different, how your school looks when you don't use the lights. Garbage Wars is another thing that you can participate in as students. You can organize this during your lunch hour. This school is in St. Paul, Minnesota, in our capital city. And what they did was at each grade level's lunch, they had everyone put their garbage, their organics or their food scraps, and then their recycling in a different bucket to see how much they could decrease the amount of trash that was produced at lunch. So they made it a competition, which was really fun, and got people talking about it. Several schools like to organize bike to school days. There is a national bike to school day. I think it's in May in the United States. I'm not sure if Canada has something equivalent. But you can pick any day you want and encourage people to bike or walk to school that day, including your teachers. A lot of schools have started to put in hydration stations. These are the drinking fountains where you can put your water bottle underneath a nice stream of water to fill it up, to encourage people to not use single-use plastic bottles. And some schools even go as far as to not sell single-use water bottles, and they just use these, or encourage kids to just drink out of the water fountain. Schools have become idle-free, or have idle-free zones where parents come to pick students up after school, and they have to turn their engine off while they're waiting for their student, while they're waiting for their child. And so this decreases the pollution that you have around a school, which is good for everyone's health, but it also decreases the amount of gasoline that each car uses because they're not idling. Within your school, within a particular class, or even just on your own, you can become a citizen scientist. And what that means is that you actually become kind of a helper to scientists that are doing research out there. So this first one is called COCO-ROSS, the Community Collaborative Rain, Hail, and Snow Network. You become a scientist helper by going out to collect information in your community every time it rains, hails, or snows. And then you send that information in, and scientists use that when they are putting together maps of, hey, how much did it rain today in the Stratford area? How much did it snow today around Sterling? So it's a neat way to get involved, to practice data collection and graphing. And then, like I said, you get to send your information into a scientist, which is pretty cool. Nature's Notebook is another great organization to be a part of. They are a little bit more focused on phenology. So when do the plants bud for the first time? When do the leaves come out on trees for the first time? But you would go out into your schoolyard and you would keep notes as to when those things happen. And then you would send that in. And the scientists use that to see if there's any changes, maybe because of climate change. Are buds on trees coming out earlier because of climate change, or maybe later? And what is the effect of that? Drawdown is a new book that came out a few years ago, and it's the most comprehensive plan ever proposed to reduce global warming. There are 100 solutions in this book, things on food and education, land use and transportation, and it just lists how much carbon dioxide would not be released if you participated in that solution. And this is across the globe. This isn't just for the US. So number 3, which is one of my favorite solutions, is reduced food waste. If the world reduced the amount of food that we wasted, we would save over 70 gigatons of carbon dioxide from going into the atmosphere. And that's a really easy fix. Not wasting food at lunch and dinner time. Not wasting food at your house in your refrigerator, making sure you eat everything, but then also talking to farms and factories and making sure they're not wasting food either. Because in the United States, 40% of our food is wasted, doesn't get eaten by anyone. So we really want to drop that number. and we can really save some CO2. Number 8 is solar farms. So the ability for people to get their energy from big solar farms, big areas that have solar panels on them. This is number 8, and it would reduce about 37 gigatons of carbon dioxide. This one costs a little bit more to implement, but it's a great way in order to not have as much CO2 going up into the atmosphere. We released a school board resolution toolkit last year. And what this means is that you as students can create, using a template, a resolution or a document that your school board or your district would sign, and basically it would say, we want our school and our district to teach about climate change. And everybody would need to be on board with that and teach about climate change, both the impacts of it and the solutions that we've been talking about today. So it's a really cool way for your voice to be heard, even though you're not able to vote yet, but you can still lead in your school and in your district and help the rest of your students in your district know about climate change and be taught about it. Maybe your future job could be a solution to climate change. There's a lot of green careers out there, and a green career is just something that's a career that's going to improve the environment. Some of those things would be outdoor-based jobs like wildlife preservation, auto manufacturing, or now looking at electric vehicles, renewable energy jobs. In the United States, the wind turbine service technician, the person that fixes the wind turbines, and a solar panel installer are the 2 fastest growing jobs in the country, which is pretty incredible. So some other titles of environmental jobs or green jobs would be environmental engineer or energy auditor, conservation scientist. So you're thinking about which career you want in the future. Maybe think about something that's more green. All right, teachers, you're up. Climate Generation has a curricula suite that we offer for free for teachers in order to teach climate change and energy education. Everything's interdisciplinary and science-based and starts in grades 3, goes through grades 12. So check that out. I'll put the URL up at the end. We also offer professional development. So we'll be in Washington, D.C. this summer, doing our Summer Institute for Climate Change Education. And this focus, the focus of this particular professional development will be on humanities. So social studies and English language arts teachers are encouraged to apply, but even if you teach science, you will absolutely still learn something. So, all right, we are coming to the time to ask questions. Teachers, if you feel you have questions personally for me afterwards, feel free to email me. There's my email there, and our website for Climate Generation. So I will quit sharing my screen and move into questions.
All right. Thank you so much, Jenna. And we'll pass along that info too, so you didn't need to copy it down. We'll put it in an email to all the classes afterwards. 2 quick notes before we dive in. First of all, National Bike to School Day is May 8th. So I got that up on my computer. It is a US-based event, but you guys can take part. And in Canada, if you want to join in solidarity, it's warm enough by then. And I'm so glad Drawdown got brought up. One of the best books you guys can get for your classrooms. It's an amazing resource for climate change. We've also got a couple classes that couldn't join in live but are watching on YouTube. So if you guys want to type in your questions in the chat bar, I'll pass them directly on to Jenna. So please do that. Don't be shy. But right now, we'll start by going with Miss Park's class. If you guys have a question to kick us off, come on up. Yeah, you're good to go.
So what percentage of light, like the light bulbs, what percentage of the pollution is caused by light bulbs?
Oh my goodness, that is a very specific question. And unfortunately, I do not have the answer for you for that. However, when we think about power generation in the United States, I believe about a quarter of our greenhouse gases come from power generation, and about a quarter from agriculture are the 2 biggest. Don't quote me on those numbers, but I would be more than happy to look up if I can find something more specific for you on that one.
Yeah, and I'll pass along Jenna's email as well, since she included it in her presentation. So if you guys want to follow up, if you have more questions after we're done here, you're welcome to follow up. And yeah, one of the nice things too with lighting, LEDs, fluorescents, especially LEDs, are really making it a lot easier to save a lot of energy with lighting. So install those at home and in classrooms. Helps a lot.
There's a great activity in one of our curriculum, as well as many other curriculum, about doing an energy audit in your school, so that you can go, count the different light bulbs in each classroom, what types of light bulbs they are, and figure out if there's changes that you can make in order to, one, save money, but then two, also save in pollution.
Very cool. All right, Miss Goddard's class, if you guys have a question, come on up.
If there's more CO2 in the water, would it put out a fire faster?
I don't think it would. It gets dissolved. CO2 gets dissolved into the water. And what it ends up doing is it makes the water more acidic. Have you guys done experiments with acids and bases yet?
Maybe.
No?
What do you guys think? No.
So maybe that's something that you could do to look at what the difference is between neutral water and then what makes something more acidic or more basic. And there's a number of different activities that you can do around looking at ocean acidification and what that means. One of the biggest problems that we have with the ocean becoming more acidic is coral bleaching. And I know there's another awesome presentation coming up from Exploring by the Seat of Your Pants from someone that's been working a lot on coral bleaching and what's happening around the world. But basically, it's killing coral around the world.
Yeah, I'm glad we brought that up with ocean acidification. It's something that doesn't really resonate with people like you say the words and people don't know what it means, but we do a lot of ocean-based hangouts that cover that very topic. So thanks for highlighting that and for the plug.
Absolutely. And I'm from Minnesota, so we have no ocean here. That's hard for us to talk about too.
We have a class, Miss Tishkoff's class. So they are a grade 6 in Woodbridge, Connecticut. Their first question, what do you think will change in our daily lives if the temperature of the earth increases by 2 degrees Celsius? These are very deep questions we're getting today.
They are very deep questions. You guys are really challenging me, and I do appreciate that. A lot of the things that I mentioned on the page when we talked about impacts are things that are already happening, and we're not up to that 2 degree increase yet. We're about 1 or 1.2 degrees, I believe. But we're going to see just more of that. So more extreme weather, longer droughts, more flooding incidences, again, depending on where you live. Stronger hurricanes are something that we've definitely been seeing over the last several years. We are basically changing the chemistry of our atmosphere. And so an analogy that I like to use with students is, how many of you like to bake? Raise your hand if you like to bake stuff. Awesome. Bring in treats for your teachers. But when you bake things and say the recipe calls for white flour and you don't have any white flour, you put in wheat flour instead. Are you still going to bake a cake? If you have to choose different flours, you're still going to come out as a cake, but it's just going to be a little bit different. And that's really what's happening with our atmosphere. We're still going to have hurricanes. We're still going to have winter storms. It's still going to get really cold. But overall, we've changed the atmosphere. So everything's going to be a little bit different, a little bit more extreme.
Right. One of the things we've been highlighting in the last few climate change hangouts too is that 2 degrees doesn't sound like a lot, but that's a global average. So we get places where they're going to increase by 10, 15 degrees. We're going to get changes in precipitation. We're going to get lots of things that, Jenna, you and I have already experienced in our lives, and the teachers have experienced the changes in their lives, and the students will start to see that difference too on a year-by-year basis. So I'm glad we got that covered.
And if you think about the last time you had a fever, your fever was probably only 2, 3, 4 degrees difference. But I bet you felt really awful, really cold and chilly or clammy or, tired. And really that's kind of what you can think about the Earth is going through. The Earth has kind of a fever and is going through these different impacts.
Great analogy. I haven't heard that before. All right, let's go to Sterling, Ms. Langlaw's class. If you guys have a question, come on up.
How much pollution is produced in 10 years?
Oh my goodness, another really specific question. 10 years of pollution. That is a good question. And again, I don't have a specific answer for you. Where are you guys located? Where is that school located?
They're Sterling, Ontario.
Ontario.
Kansas.
They're everywhere.
Awesome. Well, again, it's another question I would love to look up and find a specific answer for you. If you guys want to email me specifically, we can have a more detailed conversation about that.
Very cool. One of the things you highlighted in the drawdown book, though, so you were talking about specific solutions, and it was gigatons of CO2. So what is a giga, so that classes know what that means?
It is an incredibly huge number that even I can't wrap my head around.
We're talking a lot of pollution here, billions of tons around the world, guys. All right, and then Ms. Ramirez's class, come on up.
How does climate change cause extreme natural disasters?
Yeah.
Good question. All right, so we start back with how much greenhouse gases we're adding to the atmosphere, and those greenhouse gases, like carbon dioxide, their job, or what they do, is they hold on to heat. So as we add more greenhouse gases, we add more heat or energy to the atmosphere. As we add more energy, electrons and different atoms in the atmosphere get more excited, and they hold more energy, and therefore create bigger storms. Right? So we're changing the chemistry of the atmosphere, and that we're able to. The atmosphere has more energy in it, and it creates bigger storms. Great question.
Great question. So that's for things like hurricanes, and then with droughts and then floods, that's just a matter of more rain or less rain in various places, which again, climate change is going to increase and has been increasing for many, many years now. So lots of ways. It's a great question. All right, let's dive back in with a second round of questions, guys. Let's go back to Ms. Park's class. Come on up.
He's coming up.
Hello. I got a question. So, since the end of the Ice Age, which is 11,700 years ago, the temperature of the Earth has risen 12 degrees. Is this a major effect of climate change, especially because modern humans originated 2.5 million years ago?
That's a great question. When we look at history back that far, 12,000 or so years ago, we did have humans, but they weren't producing extra greenhouse gases. That extra greenhouse gas production really started during the Industrial Revolution. So in the 1800s, when we started making cars, we started burning fossil fuels, burning coal and natural gas. And so the big changes around that we're experiencing now with climate change impacts really started around the 1800s.
Yeah, I'm really glad we got that question too. A lot of times when we do climate change questions, it revolves around, climate has changed before. One of the big differences with this is how fast it's changing. Temperatures have increased in the past, but in 200 years, we've gone up over 1.5 degrees, which is a scale unprecedented. So great question, guys. All right, Miss Goddard's class, come on up.
If nobody did anything whatsoever about climate change, what would the world be like in 2050?
Oh my goodness. I don't want to even think about that. But that is an excellent question. We'd really see an increase that is by 2050, probably more like 4 or 5 degrees. Not sure. I usually look end of century, but by 2050, we would definitely be seeing more of an increase. And you just think about all the pollution that happens because of burning fossil fuels. If you've ever driven by a coal plant or seen even a train filled with coal and all the pollution that comes from that. So it would basically take our timeline and what we're expecting to happen and really speed it up. And so we'd see a lot more of those extreme weather events, droughts, and sea level rise happening faster than we initially thought.
Which nobody wants. All right, Ms. Tishkoff's class has a second question online, and that is, if we could go back in time, what do you think we should have done to help the future?
Oh my goodness.
These questions
That is a deep, deep question. Students are amazing.
Yeah.
Really, the amount of progress that we have made as a country and in our world from fossil fuels has been great. It's important to remember, we've all benefited from fossil fuels, The house that I'm sitting in right now was created from fossil fuels. I have a furnace downstairs that's running on natural gas. But I think if we would have known the consequences that would have come out of our use of fossil fuels and how much we rely on them, I think we could have maybe used less of them and maybe thought about some different technology like we are thinking about now, solar panels and wind turbines and even wave energy and some really interesting technology. Maybe that would have happened faster.
Yeah, great question. I want to highlight too, so for the classes, in your guys' generation, you guys have grown up with this knowledge that we are impacting the earth from a very, very young age. And in our generation, and certainly older generations, the thought was that the earth was so big that we couldn't possibly have an impact. And so we're learning that now, and I love that answer. So thank you so much, Jenna. All right, Miss Langlois' class, come on, guys.
Does the core of the Earth affect the greenhouse gases?
No, not to my knowledge. It is so deep within the Earth. So what the core really affects is the magnetism of our planet. And so if you have a geology class, you'd learn more about the magnetic field that protects our planet. But no, the core doesn't affect climate change or greenhouse gases. Good question.
All right, and then we'll wrap up with one last one from Ms. Ramirez's class. Come on up, guys.
Nice and loud.
If a power plant were to explode, would it affect the atmosphere?
Yeah, absolutely it would. It definitely, because there's a lot of different chemicals that are in there. Even if we just think about the coal or the natural gas or the oil that's in a power plant. And so a lot of those effects would probably be very localized. A lot of air pollution would affect your neighborhood. But because the atmosphere is just one big gaseous area, all of those gases would get into the atmosphere and would add to our amounts of carbon dioxide and methane in the air already.
Awesome. All right, Jenna, I think we could probably go all day, but we'll do it where classes can reach out to you individually if they have more questions.
Absolutely.
We'd like to end, is there any, I know you focused a big part of your presentation on solutions that classes can implement, but is there anything else you want to highlight right now, resources classes can go to, things they can do immediately when they're done this presentation? Anything else that jumps out?
Because this book is so awesome, I'm just going to plug it again. I mean, obviously our resources from Climate Generation are great. Teachers, please check those out and email me if you have any questions. But Drawdown has really done an amazing job of being very solutions focused and very positive about what everyone can do to be a part of the solution. Here's just another quick page on composting. And so it just gives a short introduction about what that is and how you be a part of it. And again, ranks it in order of 1 to 100. So the website is amazing. You can go to it right now and check out all of those solutions. And there's actually a competition right now called the Drawdown Eco Challenge that's happening. Classrooms can be a part of it and compete against other classrooms, I think around the globe, to be a part of the climate change solution.
Super cool. Thank you so much, Jenna. And what we do at the end of every hangout, and boys and girls, if you guys could get ready, I'm going to demute everyone's microphone. So if you guys could join me in saying a huge thank you to Jenna. Everyone is demuted.
I'm in front.
All right. Thank you guys so much.
Thank you.
Jenna, that was great. Thanks for taking part in our amazing April Climate Change Research Month.
Thank you so much for the invitation. I really had fun.
Awesome. We hope